Hi, Miss Patterson here. Today we're going to do elements, compounds, and molecules. This is for physical science. This is the chemistry side of physical science. So let's talk about matter. And matter is going to be anything that takes up space and has mass. So I like to do what's called a box test. If I can put it in a box, and if I can take it into another room and open the box and it still be there, it's going to be matter. If not, it's something else. So let's pretend I have a box and I put a leaf in that box. If I put a leaf in that box, I go into the house or I go into my classroom and open it up, is the leaf going to be in the box? Yes, so that's going to be the proof that the leaf is matter. I take sunlight. I go outside, I open the box, I put sunlight in the box. I come back into the classroom, I open it up, is the sunlight in the box? No. Okay, so sunlight's not matter. I go outside and I scare a skunk and I get that skunk smell and I put that skunk smell in the box. And I come back into my classroom and I open the box. Is that skunk smell still there? Yeah. So the smell that the skunk sprays is molecule, and that's matter. If I got enough of that, I could have mass. Now here's a trickier one. If I put a box above a fire and I just trap the heat, I'm not talking about the smoke, I'm just trapping the heat from the fire. When I take it and I put it into the box and I go into the room and I open the box, is the heat still in the box? All right, it can be, right? But if I let it sit for a long period of time, what's happened to the heat in the box? It's dissipated. So there are a couple things that can act like matter, but over time, they're not going to be able to sustain that. So if I put the leaf in the box, if I put the skunk smell in the box, that's going to stay there for a pretty long time. If you've ever had an animal sprayed by a skunk, the smell stays for a while. If I do that with heat, it's not going to happen. It's going to go away. So that's going to show that it's not matter. Matter is also called a substance. It can be what we also call a pure substance. That means it's only made of one type of atom or compound ratio. And something that is either an element or a compound could be something like silver. Silver is Ag, so I can find this on the periodic table, so it's an element. So this is a pure substance. This bar is made up of only silver atoms or silver elements, and so this is a pure substance. If I have salt, salt is a compound. It's made out of sodium and chlorine. It's a fixed ratio. This means that everything in here is salt molecules. This will be a pure substance too. Elements are going to be atoms that are all alike, and you can find these on the periodic table. When I look here at the periodic table, this is a periodic table, these are all the known elements that we have, and you can see that these are very specific to the type of atom. If I have aluminum atoms, they're all going to be identical. They're all going to be the exact same size and shape. They're going to have the same number of protons, neutrons, electrons. They're all going to be the same. So when we look at something, for example, like gold. Gold is Au on the periodic table. This is a pure substance. If all I have in here are gold atoms, so I have a bunch of these atoms, they're all exactly the same, and I have them in here, this is an element. I can actually hold an element in my hand. I can have other ones, oxygen. Oxygen's on my periodic table, and so this is also an element. If I have a container full of just pure oxygen, then I have a element, it's a pure substance. Another one could be helium. If you've ever had a helium balloon, you have a element inside of that. It's this helium gas. Helium molecules are inside that balloon. And I can show them as bonds. So here I have two nitrogen atoms. I have nitrogen right here. And these are bonded together. If I have two or more that are bonded together, I can also have an element. So N2 is an element because all I have are nitrogen atoms. Same thing if I have hydrogen. I have hydrogen pieces. They're bonded together. So that would also be an element because all I have are hydrogen atoms together. There are 90 natural elements. The rest are synthetic, and synthetic means that they're man-made. They've been made in a laboratory. I cannot find them naturally out in the Earth's crust or someplace else. So all of these here that are shaded, these are ones that can be made inside of a lab, but they're very unstable. Some of them are radioactive, like uranium. So they don't stay around for a very long time. So if they make them, they're unstable and they might fall apart or disintegrate into something else. And so they'll only be there for just a little bit of time. Elements on the periodic table have a very specific setup. So you notice some of them are just one letter. So here I have H, B, C, N, O, F, and they're all capitalized. You notice that? What do you notice about the ones where I have two letters? What do you see? I see that the first letter is capitalized and the second one is always lowercase. I look over here, neon, capital N, lowercase e. I look at tin, capital S, lowercase n. I look at calcium, capital C, lowercase a. And there's a reason for this. If I'm putting together a formula and I have something that, for example, is copper, I have capital C, lowercase u. If I happen to miswrite that and do a capital C and a capital U, I no longer represent copper. I am representing carbon and uranium, and that is something I don't want to put together. So that is why it's so important when you're writing formulas, you know what you've got. When I start to break down pieces, I need to know what I have, and to do that, you denote that with a lowercase letter and a capital letter in front. So a compound are going to be two or more elements that are chemically bound. That means there's electrons on the outside of the atom, and that's what's going to pull and push other atoms away from each other. So for it to be bonded, it's going to be bonded through those electrons. It's going to be a fixed ratio, and that means I'm always going to have a set number. So let's look at water. Every single water molecule I ever come in contact with will always be two hydrogen atoms and one oxygen atom. If I do not have two hydrogen atoms and one oxygen atom, I have something else. I do not have water. If I had H2O2, I do not have water, I have hydrogen peroxide. And that's going to be totally different than water. Here I have chalk. And you can see here I have a capital C, lowercase a. So this is telling me this is calcium. And here I have a capital C and a capital O. This is carbon and this is oxygen. If this happened to be lowercase, I would have a capital C, lowercase o. That would be cobalt. And this would be something totally different than chalk. So it's real important to make sure we're writing out our formulas correctly, and we're going to talk about that in our next part. I can also show that with different colored models. Okay, this is called a stick and ball model. So here I have a nitrogen, here I have three hydrogens, and these are going to be electrons will get passed back and forth between these bonds, so that bond is showing materials getting moved back and forth. So here I have a compound because I have nitrogen. I can find that on the periodic table. I have hydrogen. I can find that on the periodic table. And so that shows that it's a compound. I can break a compound back down into parts on the periodic table. If I can't do that, then I already have an element. So it has to be, so here's an element, here's an element, here's an element. I can break that down into my elements. But together, when I have two different ones together, I have a compound. I have water, hydrogen, oxygen, okay, and I can show that as a compound bond here. So this represents my hydrogen, and this represents my oxygen. Properties from compounds can have different characteristics than they do with their individual elements. So let's look at this one. I have sodium. This is elemental sodium. If I just have sodium, it's a very soft metal. It cuts like butter. I could take a plastic knife and just cut through it. It's going to cut and it's going to oxidize a little bit. It means it's going to change colors a little bit when the oxygen hits it. It's not going to be very friendly with oxygen. It's not going to want to be there. Here I have chlorine. It's a green gas. It's poisonous. It can kill you on its own. Just chlorine by itself is very, very deadly. And so these two together, though, if I put these together and make a bond and I push my electrons back and forth between a sodium atom and a chlorine atom, you get salt. So here I have sodium and here I have chlorine. You can eat salt. I can put it on food. I can put it in water. I can go to the beach and go in it, and it's not going to harm me in a detrimental way. Of course, if you have too much, it's blood pressure, all that other stuff. But if I'm just going to have it on French fries, I'm going to be all right. So this is something totally different than its individual parts. Here I have another one. Here I have oxygen. Remember, oxygen's a gas. It's going to be very flammable. This is what makes fire burn. So being in the presence of oxygen makes a flame burn. I have hydrogen. Hydrogen, again, is very flammable. If you've ever heard of the Hindenburg, it was a big blimp that was full of hydrogen gas, and that's what caused it to float. But when it came into land in New Jersey at an airfield, there was a spark, and just that one spark was enough to cause all of this hydrogen to catch on fire. And that Hindenburg crashed and just engulfed in flames within just seconds. So very flammable. So is oxygen, very flammable. But look what it makes. It makes water. And what puts out fire? Water. These can make fire on their own, like very flammable. But you put these fires out with water. So this has a very different properties and very different characteristics when they're put together than they are in their individual forms. And then another thing too, these are gases at room temperature. But water at room temperature is a liquid, not a gas. So that's another weird property. So characteristics of elements can change when I put them into a compound. A molecule is going to be an atom that forms a chemical bond. So a molecule can be two elements together. So here I have an element, and these are going to be a molecule because I have a bond going back and forth. Here I have a compound because I have different atoms put together, but they're passing material back and forth. I have a bond between these atoms. So this is also a molecule. Here I have material going back and forth, and I have different atoms. This would be a compound, but it's also a molecule. So whenever I have two elements, atoms bonded together, then I'm going to have a molecule. So let's look at these. Which of the following would be considered an element? So you need to think, all right, can I find it just on the periodic table? Is it only bonded with itself? If so, it's considered an element. So I look here, I see nitrogen, which is by itself, so I know that's an atom. That's one, is going to be on the periodic table. I have hydrogen here. This is also on the periodic table. This is not an element because look, I've got two different ones here, so that's not going to work. These are the same. These are the same. That is different. I have oxygen, carbon, and oxygen, so that is not an element because I have different pieces there. And I have different pieces here. So my elements are going to be these. All I have are the same atoms bonded together or by themselves. So which of the following are compounds? So compounds are when I have two different elements together. So they have to be two different ones. That's the key. So when I look, this isn't going to be a compound, right? Because all I have are the same atoms. So this is not a compound. This one is because I have nitrogen and I have hydrogen. So I have different elements bonded together. This is not a compound because I have two N's. This is a compound because I have two oxygens and one carbon. So they're different. Here I have water. I have oxygen and two hydrogens. So this is going to be a compound. Now, which one are just atoms? So now we're looking at just like a singular form. An atom is just one. So here I have hydrogens here, but I have two. So they're not just one. I have two nitrogens here. It's an element, but I don't have one. When I have one, it's considered an atom. So here's an atom, and here's an atom, and here's an atom, and here's an atom. But together they're going to be a compound and they're going to be a molecule. Here it's just one. I'm not bonded to anything. I'm just by itself. So this is just an atom just doing its thing. So those two are going to be my atoms. I look at molecules. So a molecule are going to be any atoms that are bonded together. Remember, those electrons in that outermost shell are going to be I'm passing material back and forth between them. We're going to get more in depth with that later. But for right now, just think of it, I've got stuff being passed back and forth between these atoms. So if I have that, then anything that has a bond is going to be considered a molecule. So all of these are considered molecules because I have material, I have a bond pulling these pieces together. This is not a molecule because I only have one. I'm not bonded with anything, I'm not pulling anything to it, but anything that has more than one and they're stuck together in a bond is going to be a molecule. So now let's look at this box. We're going to kind of start thinking about material and what's all there. So each of these dots represents an atom, okay? So what is inside this box? This box is just going to be a group of atoms. They're all individual, but this is also considered an element. So this could represent like oxygen, I could have helium gas. These are all helium atoms, and they're all in a helium tank waiting to fill up a balloon. And so this would be an element because all I have are the same type of atoms, but they're all individual atoms living in this container. Now let's look at this one. This one I have different colored dots. So these different colored dots are going to be one type of atom, and the purple are going to be another type of atom. But are they touching? Are they creating any type of bond? And you'd say no. So these are considered different atoms living together. This could be something like our air. We have a lot of nitrogen. We'll say the purple are nitrogen. This yellow could be oxygen. So here I have nitrogen and here I have oxygen living in our air. It's just a mixture of atoms, mixture of elements. So now I look at these and you can see I have two of the same. These are all the same color, so these are all the same elements. So these are not a compound, because remember a compound is two different ones. And these are the same color, so these represent the same atom. So what do you think is inside this box? These are just elements, okay? They're not atoms. So think, why wouldn't they be an atom? Because an atom is just one, okay? But these are going to be elements now. These are considered an element because I have more than one bonded together in a molecule. What is in this box? What do you think this is? What is that? So I look and I see I have a gray atom and I have two red atoms. So that means that I have two different types. So this is going to be a compound. So I have compounds inside this box. This could be carbon dioxide, okay? I could have carbon dioxide gas inside of a box, and then I would just have, it would be a pure substance because all I have are carbon dioxide molecules. I have these compounds. And so this would be inside of my box. So what do you think is inside this box? So this would be different compounds. This would be a mixture of compounds. I've got these compounds right here. I have these compounds right here. So these are not touching. These are not touching. So this is not making a different compound. But these are just compounds that are just living together within this box. Now we look at this one. What's in this box? So this box, I have different atoms. So this is a compound. I have singular atoms. So this is just an atom or an element. And this is living in this box. So what I have are compounds. These are my compounds. And elements. These are my elements. Okay? So looking at these boxes, we're able to kind of start figuring out, just by looking at molecules, do we have compounds? Do we have elements? Are we looking at just an atom? So we're trying to start to differentiate what we're looking at for when we move on in this chapter. All right, that's it for right now. So that was elements, compounds, and molecules. If you guys have any questions, let me know. We'll talk to you later.